All right, so finding the inverse of a function, again, the first thing that you want to make sure is that it is 1 to 1. So to find the inverse of the function defined by f, that is f of x equals to y, we want to first replace the f of x with y. All right, that's the first thing that we want to do, replace the f of x with a y. Then the second thing we want to do is interchange our x and our y in the equation defining the function. So wherever we see an x, we'll swap it with the y. Wherever we see a y, we'll swap it with the x. Then the next part of the question, the next step of the solution will be to solve for y of the new equation. And if this cannot be solved uniquely for y, then the original function has no inverse. Which also goes back to if it wasn't 1 to 1, then we cannot have an inverse. All right. So, and last but not least, we replace f of x with, we replace y with f inverse of x. So, f of x equals to 2x plus 7. So the first step is we are going to replace this f of x with y equals to 2x plus 7. That's our first step. Our second step will be taking our y and our x and interchanging them. So this will now become x equals to 2y plus 7. All right. Now our third step says that we want to solve for the new y. So that means we want to take x equals to 2y plus 7. And now we want to solve for y. So subtract the 7 on both sides. And x minus 7 equals to 2y. Then we are going to divide both sides by 2. And then we can say y equals, or here in my step 3, y equals to x minus 7 divided by 2. We are not done yet, for we need to replace y with f inverse. So we are going to say f inverse of x equals to x minus 7 divided by 2. And then that is our inverse. All right. All right, so if we do another example, let's say g of x equals to 7x plus 8. All right, and we want to find its inverse. Well, again, whether it says g or f, we are going to replace that with a y. And so y equals to 7x plus 8. So that's our step 1. So step 2, would we interchange our x and our y. So this will be x equals to 7y plus 8. Then our next piece would be to solve for y. So that means now we are going to subtract the 8 from both sides. And x minus 8 equals to 7y. Last but not least, we are going to divide both sides by 7. So y will equal, if I bring it up this way, y will equal to x minus 8 divided by 7. But we're not done because we want to make sure we write it as an inverse. So we would say f inverse equals to x minus 8 divided by 7. Okay? Now we can do one more, which would be, let's do something with the square root or squared. So let's take a look at if we have, for example, g of x equals to negative x squared minus 8 for x is greater than equal to 0. So technically the last question I didn't really determine if it was 1 to 1, but if we look at x squared minus 8, that is what? A parabola turned upside down, or negative x squared minus 8. That is parabola turned upside down, but we're only looking at half of the graph that is greater than 0. So it is really 1 to 1. But let's solve and make sure we can get our inverse. So we can say y equals to negative x squared minus 8, right? We interchange your x and your y's, so this will give you x equals to negative y squared minus 8. Now we need to solve for y, so that means we are going to add an 8, oopsies, add an 8 to both sides, and x plus 8 will equal to negative y squared. Then we would divide by negative 1 because we're not looking for a negative y squared, right? So I divide by negative 1. And then this would give us y squared equals to negative x minus 8. Now, if you remember in previous chapters, in order to get rid of the y squared, we would do the square root property. So I would take the square root of this side, the square root of this side, and y would equal to the plus and minus square root of negative x minus 8. But because my directions say greater than 0, that means I want nothing but the greater than, meaning the larger numbers, meaning I do not want to use the minus of this. I only need to use the plus of this. So that would be f inverse of x equals to the square root of negative x minus 8. And then that's my final answer, finding my inverse. And again, that's only because it says greater than or equal to 0. So that means we want the larger numbers using that plus. Okay, right? So again, when we're looking at the graphs of inverses, the graphs of the function and its inverses are symmetric with respect to the line y equals x. So it's almost like a, what do we want to call it? Remember we said symmetric across the what? Across the origin, right? So here in the blue, we have the original graph, and then here in the red, we have the inverse graph, right? Now, the best way that I look at it is, number one, again, we want to make sure that the graph is 1 to 1, right, to get its inverse. But then number two, very similar to when we were using those ordered pairs, I would do the same exact thing, except for I would plot those new points. So what I mean by that is we're going to scroll down here to my example here, right? So I have a nice, weird looking L-shaped graph, right? If I turn the L to the side. Now, what is this point here? This point here is a negative 3 and a negative 2. So that means its inverse of these numbers would be a negative 2, negative 3, right? Now, same thing goes for here. This point here would be negative 2, positive 2, right? So its inverse of this, right, would be a positive 2, negative 2. Okay? Now, if I look at this next point, I have positive 4 and regular 1, right? So what does that mean? That means that we would do the inverse of that, and that would give us positive 1, 4. All right? Now, if I had to, again, I'm going to graph what's in blue. So that would be negative 2, negative 3. So that's my first point, okay? Because I'm graphing all of the inverses. So then I would graph a positive 2, right? Negative 2. So there goes my next point. Oh, well, Miss Parker can come over just a little tad more, right? Oh, I don't have an eraser on there. Okay. Then my next point is 1, 4. So I come here to 1 and go up here to 4. So now I connect my dots. Boom, boom, and boom. Oopsies. And I have my weird looking L-shaped graph. All right. So again, when we are looking at our inverses as graphs, right, we would want to try to take our numbers, right, our ordered pairs, and just invert the numbers. Okay. So if I take a look at my next graph, all right, which I am going to give to you now. Let me, I got all kinds of stuff going on here. And copy this over here so you can see. All right. So now I look at this graph, right? It is nice, it's lovely, it's 1 to 1, all that good stuff, right? Now, I would find or identify key points on this graph, all right? Are there any key points that you can identify on this graph? Any? What would be this point right here? Well, it looks like it's going, this is 2, this is 4, that's 6, and that's 8. Looks like it's going by increments of 2s. That's 2, that's 4, that's 6, that's 8. So this point right here, I would roughly say that that is what? 0 what? 0, 3, right? Then if I don't know, is there another point? 2 and 6? Yeah, we can roughly say about 2 and 6, right? 2 and 6. We're just going to roughly say. So if I was to invert these numbers, right? The inversion of these numbers would be what? 6 and 2. And the inversion of this would be what? 3 and 0, right? So that means I would come to 3 and 0, which would be right here. And what is it? 6 and 2 right here, right? We needed another point. So can we get another point down here? What would we say this would be? 2 and 1? Well, not 2 and, well, -2 and 1, right? So the inversion, oopsies, I wrote it in the wrong color. So -2 and 1. So the inversion of that would be 1 and -2, right? So if I go to 1 and -2, it'd be somewhere down here, right? So let me get to how it looks for you on your homework. If I can move it over to the other side. Where you go? Here you go. Now, which one of these looks like my newly plotted points? All right. A, B, C, or D. So remember, my newly plotted points look like this, right? One here, and one there. So which ones am I looking at? Looking at A? Am I looking at B? Am I looking at C? Or am I looking at D? It would be A. Because again, it looks like it's off on its side, and if I blow it up, is it not hitting those same points that we just plotted? Yes, it is. Okay, so A would have been, whoopsies, A would have been my answer. Okay? Does it make sense? I hope so. All right. Nice work. Nice work. Any other? So it says a size 8 dress in country C is a size 48 in country D. A function that converts dress sizes in country C to those in country D is f of x equals to 2 times x plus 16. Find the formula for the inverse of this new function, right? So we are saying that f of x equals to 2 times x plus 16. So we want to find the inverse of this function, of this f of x equals to 2 times x plus 16. What we need to do first is say y equals to 2x plus 32. So first things first, I changed the f of x and set it equal to y, and then I went ahead and did a little distribution, right? So the next piece is same thing as before. We want to interchange our x and our y. So x equals to 2y plus 32. As same before, right? That's an equals. As same before, we want to solve for y. So we're going to subtract the 32 from both sides. So x minus 32 equals to 2y. Divide both sides by 2. Or actually, we're going to do it this way. A little slightly different. Divide it by 2. And y will equal to x over 2 minus 16. So we're almost done, all right? Where we would now need to just say f inverse, right? So our inverse, f inverse of x would be x divided by 2 minus 16. Now we can convert dress sizes from country D to country C.